My topic today is renormalization QFT. Renormalization as such is a very interesting subject which has been I would rather say the subject has been well informed by the once we calculate amplitude of scattering cross section of amplitude of particles via various collisions in the elementary processes. The Feynman diagrammatics, which somehow simplifies our way of calculating those algebraic expressions, which are basically we're calculating the different perturbative expansion. In the perturbative expansion, we are calculating the terms in the interacting Hamiltonian to different orders. And each term in the perturbative expansion gives us a particular it gives us how we can calculate certain physical processes, whether Compton scattering, whether neon scattering, electron positron scattering, positron scattering, so all sort of interactions. So it's a scheme, it's a grand algorithm or computational algorithm how we can calculate these things. So one important technical thing is that once we are going to calculate or have these perturbative expansions, while calculating them, we the problem is that while calculating those different terms in the perturbative expansion, the divergent integrals which are there, they may be part of the enumeration of the calculations which we have in those perturbative expansions of orders, different orders. So each term might have a divergent integral, which may be a superficial divergent integral or it may be a serious divergent integral. So it's basically a technical problem to begin with. But while we are trying to circumvent a technical problem, we are basically trying to. It's also we are also converted to a certain philosophy where how we want to the when we compute those physical quantities in terms of divergent integrals, how we are going to regularize them by adding some counter terms. Although as a procedure it might not seem sound, but somehow it works. So I'm not talking like the mathematician of a real analysis who is somehow summing the infinite series, but we are summing a perturbative expansion which may not be finite, which may have an infinite answer. By some ad hoc tools or procedures or I would not say that a philosophy which we normally call in the subject which is known as renormalization. So till date we have been studying classical field theories a la Clean Gordon type or Dirac or then we fed to interacting field theories, and then we had a functional integral approach of studying the same via path integral formalism, and then we are basically calculating these scattering cross sections. So the machinery taught us a lot of things of calculating diagrams, of introducing Feynman diagrams, of calculating cross sections, and not only we used Green's function techniques in the interacting field theory via path integral method, but we also use Feynman diagrammatics. For each diagram, there was a particular term which was associated with it. So, how to regularize these divergent integrals in the subject? That is basically our subject of renormalization and super renormalizability, which we are going to discuss. So the divergent integrals can be renormalizable, they can be non-renormalizable, and they can be super renormalizable. And the point I want to make is that in those divergent diagrams, there can be sub-diagrams which can be infinite. The whole diagram may not be infinite, but there may be sub-diagrams of the diagram which may be uh, divergent or not calculable computationally. So, so we can accordingly they have been, I would say, um, classified as renormalizable, renormalizable, non-renormalizable, and non-renormalizable, going from very extremes to very supernormalizable to non-renormalizable. Somewhat renormalizable is somewhat in between. So we are going to study a very interesting branch of interesting portion of quantum field theory, renormalizable quantum field theory, and how we use the process of renormalization in trying to renormalize a given quantum field theory or regularize a given quantum field theory. So it's a very interesting subject which we are going to study, but let it to do it we'll just it's basically I want to just it was advertisement of how we are going to study something very interesting.